Hello again, everyone. Welcome to the second day of QTRIC's second annual Zero Emission Bus Technologies and Transit Operations Conference. A quick reminder before we begin. We've got closed captions available in both French and English, so you can enable this tool by clicking directly below the video stream if you'd like. My name is Soumya Bhavsar. I'm Project Manager on the Pan-Canadian Hydrogen Fuel Cell Bus Trial at QTRIC. And it's my pleasure to welcome you for a continued conversation on hydrogen fuel cell electric buses and fueling solutions. As part of this panel, we'll be looking at fuel cell bus pilots and demonstration programs across Canada, supported by some perspectives from the bus supply side. But before anything else, I'd also like to say that I'm joining you from Calgary, Alberta, and in the spirit of reconciliation, we acknowledge that we live, work and play on the traditional territories of the Blackfoot Confederacy, including Siksika, Kainai and Piikani Nation, the Tsuut'ina Nation, the Iahe Nakoda Nations, the Métis Nation, Region 3, and all people who make their homes in the Treaty 7 region of Southern Alberta. Now, joining our panel today, we've got Derek Hansen, who's Director of Transit Fleet Maintenance at the City of Edmonton. We've also got Erin Cook, who's Project Manager of the Bus Electrification Program at Winnipeg Transit. And we've got Chris Stoddart, who's President of North American Bus and Coach at New Flyer MCI. Without further ado, I'll invite Derek onto the stage. And Derek, the floor is yours.
Good afternoon, everybody, and thank you so much for the introduction. And I just wanted to say, very happy to be here today and appreciate the invitation and reach out by QTRIC, and very happy to be a part of this well-established and reputable panel of all-stars. I'm here to talk to you today about a hydrogen fuel cell electric bus project pilot that we are doing in conjunction with Strathcona County. And in 2021, the City of Edmonton began working with Strathcona County on a project to test the feasibility of a hydrogen fuel cell electric bus. To talk about the different agencies and partners that are involved in this project, certainly we have Edmonton Transit, Strathcona County, Rome, and Calgary, City of Calgary. Just this slide, I guess, gives you a scope of how many buses we have on the road combined, the percentage of buses for all of Alberta, then discussing sort of the percentages of our fleets that are diesel, as we all look to align our fleets to match our zero emission transmission commitments going forward. So wanted to talk about the why. So in Alberta, and specifically in the Edmonton region, we're in a great position to potentially capitalize on a significant hydrogen economy in the coming years. Alberta is already recognized as an exceptionally low-cost producer of low-emission hydrogen and has the talent and technology to be a major global player. Adding clean-running hydrogen buses to our fleet would support our climate resilience goals, improve the customer experience, and lower the city's greenhouse gas emissions. And greening the transit fleet is a major factor to contribute to a broader net zero emissions target and ultimately enable a better life for Edmontonians. This meets our city plan goal of greener as we go. So just to basically highlight a couple of notes in the city plan. So we have an Edmonton energy transition strategy, which talks about renewable and resilient energy transition, low carbon city and transportation, emission neutral buildings, and carbon capture and nature-based solutions. And we also, as a part of the city plan, have a greenhouse gas management plan, which commits to achieving 50% below 2005 levels by 2030. So quite an ambitious plan, which would result in 237,000 tons of emission reduction by 2030. So certainly we have an interest in exploring replacing our fleet of generally diesel buses with zero emission buses, committing to these goals by 2030. Our GHG reduction goals, we're looking at 169,000 tons by 2030 2030, which accounts for 71% of the city's reduction target. So this slide, pretty straightforward in terms of why hydrogen. A lot of reasons to go hydrogen. Obviously, you know, the main goal here is the emission reduction. I like this slide because it demonstrates our current, a bit of an insight into our current fleet. And so the picture on the right captures Kathleen Andrews, where we have 22 pantograph top-down pantograph chargers on 5 consecutive tracks. We currently have an electric bus fleet of 40, and we will be receiving an additional 20 battery electric buses by the end of 2022. So in addition to that, wanted to walk through, we've achieved a major milestone by developing our first battery electric buses and deploying them into revenue service. We had these in revenue service by the end of 2020. And this is all part of our commitment to integrate emerging technologies to create a more effective, efficient, and environmentally responsible transit service for Edmontonians. And as I stated, we will be bringing on an additional 20 electric buses for a total of 60. Now that puts us in a position where we need to explore some other alternatives because there are infrastructure and utility considerations when you have such a significant battery electric bus complement to the fleet. In terms of this project itself and the Alberta Zero Emissions Hydrogen Transit Project, so the City of Edmonton is the project lead, but I've demonstrated the other key stakeholders in this project, Zen Energy being a key stakeholder, Transition Accelerator, Suncor, HTEC, AMTA, and of course, certainly we're procuring a New Flyer bus with the support of Ballard, and we've got ETS, Strathcona County, Calgary, and Rome. So the buses will be demonstrated by both Strathcona County and Edmonton Transit for 23 months. So we will be exploring this from anticipating bus delivery sometime in June, July 2022, and this will go till May 2024 in regular revenue service. Daily fueling will occur at Suncor's Edmonton LPG loading facility, with the hydrogen fuel being generated by Suncor. And during this process, operational data collection and tracking will be conducted by the Transition Accelerator and used to create a total cost of ownership model and GHG reduction model specific to operation in Alberta. So key considerations with this project and things that we're looking to explore is evaluating the impacts of temperature and climate on bus performance and whether there is any impact, and certainly we would expect with lower temperatures and different climatic factors there will be an impact, and then making those adjustments in terms of our operator usage, designing routes, that type of thing, and how we might integrate this type of bus into our fleet. A big consideration is the facility side, and so I would suggest to everybody that's on the call that the bus, I would say, would be it's sort of easy to procure the bus, but in terms of what you need to do to prepare your facility, there's much more to it, and that's where some of the intricate details can come into play. And so we've got, at the moment, we're looking to deploy this out of Farrier Garage, and we've identified a paint booth that we used to utilize on the body side, and it's currently under exploration as to whether that being a feasible option with appropriate venting and HVAC system, and then the types of sensors that might be needed to be installed to accommodate this project. Outside of that, we have explored the option as well for temporary structures to potentially be constructed to do the storage and maintenance of this particular bus. This just gives a brief overview of the Suncor piece here. And for us operationally, this means that we will be transporting the bus using our internal folks to take the bus out to the Suncor site, which is about a 15-kilometer drive from Farrier Garage. Once they get to the Suncor site, the bus will be fueled by a private contractor. Some other considerations to factor in that we needed to consider during this is ensuring that our staff or those staff that might be driving out to the Suncor site have all of the on-site safety considerations and site orientation training to ensure that we're in alignment with Suncor policies and our staff are remaining safe. Brings us to the idea of opportunities and challenges. And as I've said, the buses can be the easy part. Infrastructure and safety codes and standards are the real challenges. And I would say that there aren't a lot of safety code. Like, this is emerging technology and we're almost writing the book in a lot of ways. We're following the NFPA2 standards and having our engineers and architects and safety codes folks evaluating those codes and challenges. But certainly when we're exploring one bus, that's one thing, but then what that might mean to expand the fleet, have additional buses, and if we're looking at sort of a big expansion, what that might look like and what we might need to consider on the facility side. So I've just listed a few in terms of building infrastructure, fire safety measures, exposure guidelines, hydrogen embrittlement, those types of things, and first aid. And so not only on the maintenance side, but also on the operator side. And so there is a comprehensive training program that we've been in regular discussions with New Flyer and Ballard in terms of ensuring that training is deployed, and we will have that training available to our staff prior to bus delivery. So then finally, just wanted to summarize that, you know, in consideration of all of us exploring different ways to reduce emissions and strive towards a zero emission fleet, there is a significant need to focus on the bus facility and infrastructure. The bus itself ultimately comes in the end, and we can easily house diesel and electric in the same facility. And then what does that mean to then bring hydrogen in? It's important to choose a facility or choose a garage location based on utility services, and incorporating your long-term infrastructure plan into your bus procurement plan. Also important to have a strong partnership between utility and your transit companies. And you know what that might mean to have a centralized, what we're doing, a centralized super garage, and possibly some technical garages that would incorporate diesel, battery electric, and hydrogen. And then where that particular facility is in terms of proximity to those resources and services that would be required to support that. Ensuring, you know, for us that we're building in versatility into our plans and options as the industry grows and develops, and also knowing our operations and building our infrastructure around our service. So that's what I have for you today. I appreciate being here and look forward to questions at the end. Thanks, everybody. Thanks very much.
Thanks a lot, Derek. Really interesting to see efforts towards fuel cell bus deployment at one of the few municipalities in the country, and especially really interesting to see project configuration as well, and also how it is based on certain pillars of decarbonization at the City of Edmonton. We look forward to discussing more soon, but next I've got Erin Cook from Winnipeg Transit. Erin's also in the process of deploying fuel cell buses just like the city of Edmonton. And yes, would love to hear more about your project, Erin.
Thank you, Samya. I am Erin Cook, the project manager for bus electrification at Winnipeg Transit. I've been here for about 2.5 years. Prior to that, I was at New Flyer working on developing these fuel cell buses and launching them into the field. At Winnipeg Transit, I have been working on developing the zero emission rollout plan for the city here. The first year, we really focused on a technical evaluation and determining what technology was best for Winnipeg Transit and looking at the capital costs versus the operating costs. Well, the last year, the focus has really been mapping out and planning the infrastructure purchases across our various facilities. So what we've identified is that this transition is likely going to be a $1 billion project across multiple years. It's going to result in significant GHG reductions, but there's significant change throughout our organization to accommodate the new technology. So this includes a significant amount of operational uncertainty in terms of how we're going to fuel these, what the range limitations, performance limitations are going to be, how do we get our workforce ready to service these buses, and just the overwhelming complexity involved in rolling out the new infrastructure. So if you had attended just for those of you who are not familiar with the current fuel cell buses, they are no longer fuel cell propelled vehicles. They're battery propelled vehicles where the hydrogen fuel cell more or less operates as an onboard charger. So you do have the ability to turn off the fuel cell and operate on battery power only, or if you ran out of fuel, that's an option. So really, it just comes down to a slightly different way to charge your bus. For those of you who attended my session yesterday, I talked about how complex charging decisions were. By contrast, the fueling infrastructure is significantly simplified on paper. You really only have to decide between on-site production versus delivered fuel, and then a few decisions down the line. If you are producing on-site, is it electrolysis? Do you have space and power for that? If you're using steam methane reforming, it's a little bit simpler, but not green. Delivered fuel, it's liquid versus gas. And then resiliency, if you get delivered fuel, is super simple, barely any power required. And with electrolysis, you do have significant power similar to charging that you have to deal with. But the challenge right now is a lot of people have concerns on safety, but overall the vehicles are incredibly safe. It's a very mature technology, much actually more mature than battery electric. There's very well established codes and standards on the vehicle safety side. It's built off your natural gas systems, just any lighter than air gases. There's multiple redundancies put in. There's detection on the bus and off board the bus on your fueling equipment. There's communication back and forth, just multiple safety features. All of the equipment tanks go through abuse testing, bonfire testing. I think they even fire bullets at these things. Just overall, very, very safe. Operationally, when we went through our study, we realized that battery electric buses, when you're only looking at a 10 to 20 bus pilot, are significantly cheaper. And I think that's why the fuel cell buses get excluded by a lot of people. But once you get above 50 buses or so, you really start to see the advantages of fuel cell buses. The fact that you can fuel them very quickly, the fact that their range is longer, it makes your scheduling simplifier. They're virtually a one-to-one replacement for diesel, with the exception of some weekend service in our area anyways. And the scale of or scalability is significantly improved. You're looking at buying a fueling station every 20 years versus a charger and a bus together for infinite. I talked about with delivered fuel, you have the resiliency to power outages. You're able to operate off stored fuel. These buses do produce some heat, so there's potential for them to have potentially better winter performance, no diesel auxiliary heater. But despite all these pros, there's the big con on why there aren't more projects in Canada, and it comes down to the cost of fuel. And I know there's a lot of information on this page, But basically, what I'd like to highlight is that, mostly programs from the federal level right now are focused on bringing down the cost of production, but the cost of production is only a small percentage of what it actually costs transit to operate a hydrogen fleet. So beyond just the price of producing the fuel has to be compressed, it has to be marked up for somebody to make profit, trucks have to operate back and forth, and then you have to operate and maintain your stations. So if you're doing it yourself, the costs are whatever spare parts or your labor is. But if you're on hydrogen as a service, you're paying somebody to maintain those parts and services for you, and it can add some extra costs. So these are actual costs that we've been quoted throughout our project here, and we've ultimately landed on on-site production for our first implementation here. And the system we're looking at will support about 30 buses. But for us to be able to scale up going forward, we need to look at a solution to solve the delivered fuel option, because that's really what's needed to really gain all the advantages of hydrogen buses. So right now we have a funding application underway to purchase 100 to 110 buses. Of this, 30% are fuel cell buses. So we have 33 fuel cell buses planned for our program right now, the remaining being battery electric. But we're purposely rolling this out on a systemic basis. So if we determine that we prefer hydrogen over battery electric or vice versa, we can adjust that fleet mix accordingly. But we are invested for at least 30 buses based on the fueling infrastructure that we're looking to purchase. So thank you very much for your time, and I look forward to answering questions.
Thank you, Aaron, for shedding light on a project from Winnipeg Transit's perspective. And again, really interesting to see a different kind of a project configuration and the challenges that emerge from that. That said, now it'd be great to also get some perspective from the industry side, and especially one of the key stakeholders in any such project would be the bus supplier. And so, yeah, we've got Chris Stoddart from New Flyer and MCI, and we'd love to hear from Chris about their experiences on this front. Chris, over to you.
Okay, thanks, Samia. Well, again, hello and welcome. My name is Chris Stoddart. I'm president of NFI Group's North American bus and coach business, which includes New Flyer and MCI. NFI is a leading independent global provider of sustainable bus and motor coach solutions and one of the largest bus manufacturers in the world. I'd like to start off by thanking QTRIC for having me on this panel at the second annual Zero Emission Bus Conference. I'm pleased to be here and to spend time talking about the deployment of fuel cell buses across Canada. Listen, although fuel cell technology has gained popularity in recent years, it's been around for a while. At New Flyer, we first began development of hydrogen fuel cell transit buses in 1993. And working alongside our technology partners, we introduced the world's first fuel cell transit bus. And this was followed by a 20-bus demonstration build for BC Transit supporting the 2010 Olympics. And since then, New Flyer has reached many milestones with respect to hydrogen fuel cell buses. In 2018, we delivered the first ever 60-foot fuel cell bus in North America, funded by the Federal Transit Administration's National Fuel Cell Electric Bus Program. It was the first 60-foot fuel cell bus to complete Altoona testing. In April of 2019, we introduced our Excelsior Charge H2 fuel cell bus. And later that month, it actually surpassed a range of 300 miles without refueling, ultimately reaching 350 miles during a testing demonstration with Orange County Transportation Authority. And finally, earlier this year, we announced NFI as a founding member of the Hydrogen Fuel Cell Council in the US, which is focused on advocating for and advancing adoption of fuel cell buses at scale in North America. So listen, why fuel cell? We believe the growing interest in fuel cell technology is attributed to a couple of things. First, fuel cell technology is a unique, sustainable, and innovative way, but it's there to obtain extended zero emission range. Depending on climate, topography, and duty cycle, fuel cell buses provide an immediate one-to-one replacement for conventional propulsion without requiring a great deal of planning or infrastructure changes. As agencies are moving towards zero emission adoption, the ability to deliver a one-to-one replacement to conventional propulsion is definitely an attractive feature. And fuel cell, it's really an ideal complement to battery electric propulsion, given fuel cell buses do not require significant operational changes. And secondly, agencies are gaining more experience with hydrogen refueling procedures and fill duration, as well as the cost of fueling infrastructure, as Aaron just mentioned. While there's certainly a capital cost premium today for both fuel cell electric vehicles and the hydrogen fueling infrastructure, agencies are now obtaining enough data on both battery electric and fuel cell electric bus operations to be able to project and compare the economics of fleets at scale, enabling agencies to evaluate total cost of ownership and determine the best mix of zero emission buses for their operation. So back in March of 2021 at the same conference, I stated I was optimistic that with more data and planning, we continue to see the interest in fuel cell electric buses grow. And boy, it sure has. Since then, New Flyer's had 5 orders totaling another 60 fuel cell buses, showcasing our industry's growing interest in the range extending capabilities that fuel cell buses offer. One of our first fuel cell customers, Sunline Transit, based in California, recently ordered 5 additional hydrogen buses to add to their fleet, which now consists of 26 fuel cell electric vehicles. This showcases their commitment to zero emission mobility and confidence in a fuel cell fleet. And as mentioned, we've seen growing interest in fuel cells enough so that we decided to do a fuel cell tour across America showcasing this technology with one of Sunline's buses so that they so graciously offered. This tour wrapped up only a few weeks ago after visiting 7 different agencies and after receiving some incredible feedback and data from each stop along the way. Now, although all 5 orders we received last year were from our friends across the border, as we've now heard from Derek and Aaron, the interest in fuel cell is certainly growing in Canada. It only makes sense given Canada's where fuel cell electric bus technology has been pioneered. I'll share a little bit more on the hydrogen activities we're currently undertaking in Western Canada. After listening to Derek, we're thrilled to be partnering with the City of Edmonton on their Alberta Zero Emission Hydrogen Transit Initiative. They're testing 2 New Flyer Excelsior charge buses, H2 buses in real world conditions. Again, as Derek mentioned, one will be with Edmonton Transit Service, the other one's with Strathcona County. And these buses are actually online now, ready to be delivered in the June timeframe. New Flyer is the only manufacturer producing all 3 zero-emission bus types, which include trolley electric, battery electric, and fuel cell electric. And as mentioned before, there are many benefits to fuel cell compared to trolley and battery electric. And these benefits help Edmonton support climate resilience goals, improve customer experience, deliver the extended range, and lower the city's greenhouse gas emissions. These 2 buses will incorporate Ballard's fuel cells and are excited to see how the technologies perform in Alberta conditions. These pilots are scheduled for 2 years each. We'll monitor the performance of the fuel cell buses and also be able to compare them to diesel, CNG, and battery electric alternatives. Ultimately, the data will be instrumental in creating viable strategies to move the city of Edmonton to a zero-emission fleet. And this is likely to increase demand for hydrogen buses and support deployment of economically viable fueling stations and distribution systems in the province, which are necessary to transition to a hydrogen economy that will achieve emissions reductions, economic growth, and job creation. In closing, at NFI, we believe there's an appropriate situation for all 3 types of zero-emission technologies, and the selection is highly dependent on available infrastructure, local energy rates, and the proposed duty cycle for the vehicle. As our customers move their fleet to zero emission, we welcome the opportunity to discuss the option that best fits your operational environment and demands. Thank you. I'm looking forward to discussing more about fuel cell buses and technology with this panel.
Thank you very much, Chris. Good to hear the technology perspective, and a really important background setter, especially when you tell us about New Flyer's experience with these buses and the level of maturity they are at right now. That said, I think we can dive into a Q&A session now, and so yeah, it'd be great to have everyone on the screen. Yeah, so welcome back on stage, everyone. And yeah, I was just going to start with a bit of a discussion on scoping decisions. I think it'll be of value to some of our audience members from the transit side. And so, it'd be good to just explore the decision drivers of the conception of demonstration projects in the first place. I also recognize that the purpose of these pilots, the demonstrations, is primarily to validate on-road performance of the buses, but also to do some sort of an integrated testing of the fueling system solution alongside the bus operations. But at the same time, then we're also trying to acquire operating, maintenance, and asset management experience. That said, now in the case of Edmonton and then in the case of Winnipeg and also in the case of Mississauga, we see different scoping approaches. So yeah, I was just hoping to explore a bit, on how your project objectives have driven your scoping decisions and how you weighed the different project objectives before making scoping decisions. So maybe I'll start off with Derek here. Derek, how have your project objectives shaped your scope? And also, were there any other drivers that drove you to the decision of deploying 2 buses and starting off with 2 buses and then considering scaling with a different dimension later?
Yeah, so I think to start off, I would say that when we receive the next 20 battery electric buses into our fleet in 2022, we're at kind of that point with our facility infrastructure and utility requirements where we need to explore what other options might be available outside of constructing a new facility. So that's certainly a driver, because at the moment that next facility isn't available at the moment. And I think when we're aligning our zero emission commitment and our fleet strategy plan to reduce emissions, we've also got an opportunity to capitalize on the significant investment in the Edmonton area in hydrogen. And so it's sort of one of those stars aligning type of situations where this opportunity presented itself. And we're certainly committed to the concept of reducing emissions. And so this has allowed us to, I guess, explore other options. In terms of the why one, I would say funding, and there is a ERA funding that's available, so that we're capitalizing on that, and that's something that other agencies should be considering and exploring as they're evaluating these projects. And I think the partnerships with the other agencies involved is important too, and having that commitment with the agencies. So I would say, for all of those reasons, that's sort of where we landed. In terms of our ability also to support from an infrastructure side additional fuel cell electric buses. We would have to, I guess, evaluate the effectiveness of this one first, and then go from there. But I would, funding available is a significant factor. And I guess, like to Aaron's point about fueling structure too, it does, as you can imagine, put a bit of an operational constraint when we're fueling offsite. And so, how many buses within the fleet do we want? Outside of having on-site fueling, could we commit to having that sort of off-site fueling?
Really, really interesting points there, and we'll revisit the fueling side and what kinds of scaling pathways could be explored based on constraints on that front. But some great insights there, Derek. Turning over to you, Aaron. You did note in your slides that operational uncertainty followed by workforce development and then infra uncertainty were some of the questions you wanted to try and answer as part of the demonstration phase. Did you weigh these objectives equally, or did you weigh something a little higher? Was bus performance measurement, for instance, a primary objective and something really important to you. If you can shed a bit of light on that front, that'd be great.
Well, I feel going into this, like, we're not as questioning the technology performance itself. Like, we've worked with New Flyer for a number of years on demonstration projects for electric buses, and we know that the technology is going to get there. So much more of our questions were around the operational uncertainty. And when you're doing your economic analysis, you're able to look at the price of fuel, all the basic things that you look at. But what you don't know is what is the manpower impact in order to make something work. So that's why we wanted to do the trial, and that's really what we're looking at, and that's not what we didn't get out of the last trials. Like, our last demonstration really looked at the performance of the bus, and fundamentally these are going to be the same. So we do have questions on the fueling infrastructure, and we've made the decision to accept outdoor fueling to avoid some of the major facility modifications until we're confident that in the technology as being a good suit operationally. But yeah, most of what we're looking at is what is the simplicity of operations. So on paper, a fuel cell bus seems like it would be a direct replacement with our existing diesel operations. Range is similar. Way you fuel them is similar. The way you would service them is similar. Whereas battery electric is everything has to change. So what we want to be able to evaluate is what is the cost impact on the operation side, and does that change the economic evaluation that we did before we have the actual results from the trial.
Sure. Well, that is great to hear. And just to shed a bit more light, from the perspective of the Mississauga project that we're involved in on our end here. For us, for instance, measuring performance did come out to be a very important objective as well, especially considering the size of blocks at Mississauga, for instance. And so, this does, beg for a careful assessment of what your project objectives are. That said, it'd be great to hear from Chris on, the point of view from New Flyer's side, and especially when New Flyer's had a vast experience in fuel cell bus deployments. What's left to be learned, Chris? Aaron and Derek, highlighted what transit concerns they're trying to tackle through these demonstrations. When it comes to the technology itself, we recognize it's mature. Is there anything left to be learned through these demonstrations, or is New Flyer pretty much ready to just start rolling these buses out of the assembly line?
Thanks. And Aaron, great job answering your questions. You probably answered many that I was going to say. But, first of all, the good news is we know the technology works. And so that's wonderful to see. And if I was to just highlight Ballard, I don't know what generation. They got to be on their 8th generation of fuel cell now. So, and it continues to increase reliability, be smaller in size, get better power output. And so as more fuel cell, OEMs get into that game, there's going to be more competition. There'll be more changing in technology. I really think if we can get to volume, the cost premium typically associated with fuel cell is going to come down. And our job at New Flyer, we're here to provide solutions to customer, and there's no one size fits all. So, for the teams of people that are looking for the ultimate range right now with the current state of the art of battery technology versus fuel cell, fuel cell's a winner. If the ability to refuel similar to a CNG bus, in 8 to 12 minutes, much like you refuel today, is important versus 4 hours at nighttime, fuel cell's the winner. So, I think Aaron really touched on the infrastructure is not trivial. It's better at a, scale, and whether you're trucking it in or generating it has a massive cost. Aaron, I was glancing at your slides. It's almost a 4-to-1 ratio from the top to the bottom on cost there. So, those are all factors that our customers have to consider. There's unique considerations depending on the location and the topography and, proximity to power and other sources. So our job is to provide solutions to customers in the new and emerging zero emission world that tick all the boxes. But we're really very bullish about it. You know, I've just every year that progresses, it seems to be a higher percentage of our zero emission builds are now going the fuel cell way.
That's really interesting, and you did allude earlier to volumes or supply volumes as well, and you know how the premium compared to a diesel bus is bound to come down as we assemble these buses in larger volumes. Speaking of volumes and assemblies, you know, end of the day, what kinds of signals are you looking for before you're able to consider not just ramping up volumes, but also maybe moving some of the assembly to Canada? Because you know, I bring this up, Chris, because in discussions with government stakeholders, Canadian content is another interesting thing that comes at play, right? So when it comes to assembling some of the buses locally, what kinds of signals are you waiting for? Is it just these demonstrations and pilots? Because I believe soon as you have the right signals from these demonstrations and pilots, it'd be, you know, a good signal for a player like New Flyer to consider moving, you know, some of those jobs to Canada, right?
No, well said. Listen, we've made the investment now to have all of our facilities. We're just finishing MCI, literally just finished it, to be capable for building battery electric buses. So all the high voltage training, all the personal protective equipment, the commissioning bays, the charging infrastructure, that's now all in place. So our next step is we only have one facility fully capable of producing hydrogen buses with the correct hydrogen detection systems and the hydrogen fueling infrastructure. But our plan, exactly as you said, is as the volume continues, would effectively be able to have all of our facilities that build buses be able to produce hydrogen. So it's looking more and more likely that we're going to be making that that investment now in the Canadian side to be able to produce a cradle to grave hydrogen fuel cell bus. But it's not right now, it's not within the next year, but it's certainly within our 5-year window.
For sure, and that is definitely positive and good to hear. Now, having explored a bit of the scoping side and the bus procurement side, it'd be great to explore a bit more on the fueling solution side. Now, I did want to explore a bit more along the lines of preconditions that you think are necessary for projects like these. And I'm sure that, Derek, you did speak a bit to it. Aaron, you spoke to it. But if you were to, pluck a couple of key points related to the necessary preconditions, especially when it comes to the fuel supply side of things, to really jump into this game of starting a fuel cell bus demonstration or pilot project. I'll probably start with Aaron here. Aaron, any very specific preconditions that come to mind? For instance, for climate action targets, clean hydrogen is a priority as well. So you want to have a phasing strategy as well, right? And depending on the nature, or depending on the type of hydrogen you'd like to use, a necessary precondition could be the type of electricity supply in your jurisdiction, or the availability of, for instance, carbon capture and utilization infrastructure. That's just one example of a precondition. But there could be other preconditions. Your fuel supply contracts and such. If there's a couple things you could highlight on this front, what preconditions should a transit player look at to start a project like this?
I would say that we started with local economic benefit. So in our case, using green Manitoba hydroelectricity was a requirement for our project. So that narrowed down some of our options on the hydrogen side. So we did a survey of what was available, and we have, the ability for on-site production. There is no local fuel grade hydrogen, so that was kind of out. We do have a source of byproduct hydrogen within 200 kilometers or so of the city, but it wasn't it's not established yet. So, you know, we've discussed various different people who are looking at setting up hydrogen, about the, you know, byproduct hydrogen, what we could get. Where we've landed on today is kind of the hubs model. So we're working, you know, with our local community college and the Vehicle Technology Center and other people in our area to see who might have other interest in hydrogen. So can we combine together our communal needs for hydrogen to make a business case for somebody to build production here? So, you know, there now is, you know, new interest in building hydrogen here with other projects that we may have opportunities to latch onto in the future. But in our case, we need to understand the timing of when we needed buses, and nobody to deliver hydrogen was really aligned. So if you have the flexibility to look at the timing of when you want the buses on the road, you may have options to see what's available, who can you work with. The other thing is, what's your cost? What are you willing to pay for hydrogen right now? So are you willing to accept short-term contract where you're paying $12 to $14 a kilogram to try it out? Or is your business case to try to really compare it to battery electric and what the end state is? And for us, we landed on on-site production because we can get on-site production at a price that we're hoping to get delivered fuel in the future. So that we know that if we were to go into a trial today and pay $12 a kilogram for hydrogen, the economics wouldn't be there and the technology would die at the political level. So we wanted to give the technology its best chance to be successful. So we've made the sacrifice with outdoor fueling and the extra complexity and high capital cost, and that's kind of where we landed. So there's a lot of decisions that you have to factor in, and everybody is going to land on something different.
That's really good to hear, actually, Aaron. Anything that stands out on the Edmonton front, and I'm sure that, you know, with the Edmonton Region Hydrogen Hub, of course, there's the hubs argument first of all, and transit being, you know, a seeding end-use technology for hydrogen hubs. So there's that argument for sure. Any other very specific things that enabled you to, you know, get going fast with a project like this?
Yeah, I think, you know, Aaron captured the evaluation really well, and economic benefit is certainly a driver. I think, you know, the only thing that I would maybe add to the idea of hydrogen hub, similar to what's happening in Europe at the moment, is this, you know, public and private partnerships that would enable the appropriate amount of investment for, you know, in Aaron's case, on-site production. We're not as far ahead down the line as they are, but that's certainly fantastic and something certainly we're interested in. And, you know, being able to implement something like that on our infrastructure side would be fantastic. So, you know, to Aaron's point as well, the type of hydrogen and then availability of the hydrogen. But I would say overall, that economic benefit and developing those public and private partnerships and relationships to move this forward.
For sure. And so speaking of public and private partnerships, first of all, one of the good things that comes out of those is you know, that collaboration to develop regulation or grant funding programs together. Speaking of which, you know, it'd be great to hear if you have factored in policy instruments such as the carbon pricing side of things, or the clean fuel standard in your calculations when it comes to business casing, or is it something, you know, that you wouldn't factor in right away, at least from a transit perspective, because from a fuel supplier's point of view, you know, it is promising that we'll most likely have the clean fuel standard pretty soon here, which will bring down the premium with a premium between diesel and hydrogen prices, depending on the nature of hydrogen you're using. Have you factored in these aspects into your calculations, or you know, is it something that you hold off against before really assessing your business case? I'll go back to you, Aaron. If you've if you've really seriously looked at the clean fuel standard as part of your business case, or if you still see it as a bit of an unpredictable and unreliable policy instrument to rely on for the time being, and if this begs for some more government intervention for the short-term future.
Yeah, like I'd say carbon tax, we definitely factored in our economic analysis because that's pretty set. But the clean fuel standard is totally an unknown for us. We don't know when it's going to be approved. It's been in discussion for years. We can't really wait to make decisions at this point on what might come in. The other uncertainty to me is it going to be to the producer of the hydrogen, or is it to the distributor of the hydrogen or dispenser of the hydrogen? So, if it does end up going on the production side, there's no guarantee that those are going to be passed on to us at 100%, right? So right now we're making the decisions on what we know today. But each order we reassess where we're at, right? So obviously if the economics change, that could swing one way or the other. Like our review basically showed that hydrogen could end up being the lowest cost solution or the most expensive entirely. So we're going to make decisions economically and make adjustments as things change, but we can't count on it today.
For sure, and not exactly the same question for you, Derek, but we'll use this as a bit of a leeway to talk about scaling of the fuel supply solution, because end of the day, fuel supply costs and policy instruments subsidizing fuel supply costs initially, they all tie in with the delivered cost of hydrogen at the end, right? And if you look at the delivered cost of hydrogen, distribution is a very important piece in the puzzle that needs to be solved as well. Compression and distribution both together all the way out until the point of dispensing. So you've got Edmonton, but at the same time, it'd be great if you can also shed some light on the involvement of the likes of Calgary and Rome, and if these buses will be running in those jurisdictions, and if yes, what kinds of fuel delivery solutions have been thought about, and what are just approximate plans? I recognize you can't share too much details, maybe. If you can just shed some light, because I believe this will help some of our audience members, look at the bigger picture and maybe a long-term transition pathway.
Yeah, so I guess I would say there are still some pieces to be determined on the Calgary and Rome sides, but I can say that they are evaluating a fueling infrastructure in Calgary at the moment, and that will determine or help determine their sort of plans going forward. I think to your previous question, we in Edmonton as well are projecting or building in projections on carbon pricing and carbon taxes and credits into our fleet procurements into the future. But again, I would agree that there are still a number of unknowns in terms of what those costs might look like. I think we would all agree that on-site fueling and the ability to fuel at a facility is the way to go, and that would be something that we're certainly interested in. It's not ideal to be fueling off-site, and at the same time, we've got the opportunity to do so in this partnership with Suncor right now. So where we develop that partnership, what that might look like in terms of a storage tank or bringing in trucking in hydrogen or actually having on-site production, I think we probably all agree on-site production is the ideal way to go. So I'm kind of in a roundabout way answering your question. I think more to be determined in terms of bus evaluation on the Calgary and Rome side.
Sure. I know it was a very long question, Derek, so it was good to hear a bit more on that front for sure. Since we're running out of time, maybe it'll be nice to just try to distill the last hour into a couple of final messages or some takeaways. I'll start with you, Chris. Well, from your point of view, if you were to pick a challenge and an opportunity from pilot projects and demonstrations like these, especially from the likes of the Edmonton, Winnipeg, and Mississauga projects. What challenges, what key challenges and opportunities remain as of today? Q1 2022, let's say.
Honestly, I'm impressed by the approach that those agencies are taking, because I think when you can evaluate battery electric, you can evaluate fuel cell, you're doing it in a serious enough manner that you'll get good data to in the next 8 to 10 years, every purchase of transit buses is going to be zero emission, right? And so it's a massive decision for the various agencies to try to pick the most successful path forward that gets the emission targets that's desired. But at the end of the day, these folks provide a service that has to be robust and on time and cost effective. So I think the fact that the true evaluations are taking place now, and the other challenge I would say is just it's a great opportunity, and it's very complementary, whether it's fuel cell or pure battery electric. There's a whole big upskilling of the workforce that can take place. I think it's going to generate a lot of also neat opportunities for employment. But working on high voltage, the maintenance involved with the fuel cell, just driver behavior. There's just a whole world of opportunity for future employment for people. So, I'm excited to see that unfold, and we're going to be very supportive of whichever way it goes. And like I said, I don't think it's a single way. I think we're going to see a distribution in between both technologies. Just unclear what the ratio will be in 10 years.
Absolutely. That's great, actually. I'll turn to Derek. And Derek, before we get you to answer the quickfire, quick check from an audience member here, if you can speak to the relationship between the Calgary-Edmonton trucking project, and if there's any connections with the AZEHT project. I believe the audience member must be referring to the Aztec or the Aztec project here. So yeah, if you can just quickly speak to that.
In terms of the Alberta Zero Emission Hydrogen Transit?
Yeah, so the AZEHT, and if it's connected with the hydrogen trucking project.
It's not that I'm aware of.
Okay, sure. And eventually, Derek, if you can just distill the conversation into a challenge and opportunity.
Yeah, so I guess my words to consider would be zero emission is happening. And so I think we're well aware of that, and there's a true need to adapt to that. I would suggest that no matter the agency, the approach to getting to carbon neutral or zero emission or reducing emissions needs to be a hybrid approach, needs to be flexible and nimble. The other thing that I would say, the opportunity is in the data. These buses are smart buses, and there's a heck of a lot of data available. And to Chris's previous point about driver behaviors, there are opportunities now to evaluate driver behaviors in then informing our decisions around how we can become more efficient and utilize the equipment in efficient ways more than ever before. So I would suggest, those are my final thoughts.
Sure, that is fantastic, Derek. Aaron, your final thoughts on last remaining challenges for projects like these, right? And if you see opportunities emerging after these kinds of projects.
I would say if you have an interest in hydrogen, contact any transit agencies that are underway between ourselves, Edmonton, My Way. We all have information to share with each other. And get connected with other local people who might have interest in hydrogen, even in passing. Even if other people are looking at it, it can really start driving that conversation.
Great, for sure. So I hope this panel shed a bit more light on how much due diligence has gone into consideration of these projects. and how these projects will be paving the way for, a very important industry, an industry on the bus supply side, but also an industry on the fuel side. Something that can pave the way for, maybe export-oriented business in the future as well. But more than anything, something that can pave the way for more climate resilient and climate active cities that have zero emissions fleets that are absolutely reliable as well. We encourage you to reach out to any of us should you like more information about these projects. Would be happy to discuss further. But that said, I'd like to thank our panelists for their valuable time and insights here. Thank you so much, Derek, Chris, and Aaron,